Welcome to Spring LIB.
Hello students. To independently verify the uncertainty of force measurement for for the acceleration of a cart lab, you can use the first calibration of force sensor. So this begins by calibrating the force sensor used in the experiment. So this involves applying the known forces to the sensor and recording the corresponding measurement. Okay, then use a calibrated force standard or a set of known masses to create a range of force values. So you calibrate some known masses m2 m3, and then you get a corresponding force values f1 f2 f3. So this application is what you do for this, right? Now this can help you predict the uncertainty. So for particular mass, you know how to calculate the calibration. So force will be equal to mg. So it will be equal to m1g for the first mass. Now you get a value, let's say 120 pounds. So you know the g value. You can formulate a equation for g value, and you know the exact g value at your point, which is 9.81 meter per second square, and you can just use that for calibration. Now second is data analysis. So you got the recorded data from the force sensor calibration. Now you calculate the average reading for each of these force applied, and you determine the standard deviation. So standard deviation, like using the average of all values, all readings, you can formulate the standard deviation, and then using that standard deviation you can say it is plus or minus the standard deviation values. So that is also another opportunity. A third is error propagation. So you just consider the uncertainties in other measurements involved in the experiment, like mass and acceleration. Now then you can evaluate the impact of these uncertainties on the calculated force value. So force will be equal to mass times acceleration. So it will be the error of force will be equal to error of mass times error of acceleration, right? So this is what you are going to get. You can add the errors and to get the final error. That is another error propagation. Fourth one is theory comparison. So you can compare with theoretical expectations. Now you predict some for particular 10 kilogram of mass times 9.81, so you'll get 98.1 kilograms of weight, or kilogram meter per second square of weight. So you know the value, right? You check it with your measurement and you'll find a different value. You know the uncertainty there. Fifth, you repeat this experiment and then you get the uncertainty. That uncertainty. Now fifth one is repeating. So you can just take 100 trials or 10 trials or anything like that. So higher the number of trials, higher will be your accuracy. So you can average a value, and then within that average you know the highest deviation, and that deviation you can take as an error. Okay, so that is how you do it. So I hope you find this solution useful. Thank you.